In this screencast, I'm going to describe how to work with panel data. I've got a data set on baseball teams and their attendance records, a bunch of their statistics for the period 2005 through 2015. Where I had left this last with my student was we need to include a team number to identify each team. So we've got the names for the teams, but Stata can't handle that. It can handle team number, and I've got this done. So Arizona's team 1, Atlanta team 2, Baltimore team 3, etc. Okay, so I need to get this data into Stata. That's very easy to do. I select all the data, and we've got a whole bunch of columns here. Then I am going to paste this data, just copy it, and paste it into a blank Stata data set. So here, copy it, and now I move to Stata. Take a moment here. Okay, so I've got a data editor here. So first of all, let's do a log file. Okay, so we're going to begin a log file just to keep track of what we've done. I'm going to put it here, and let's see. So read into Stata. Okay, so there we go. All right, so go to the data editor and hit Control-V, paste. I've got the data here. We've got year per capita income. Notice the dots, those indicate missing values. We don't know what the per capita income is in those years. Same thing for population. The league and team is in red. Those are string variables. They can't be handled by Stata, at least not too easily. Team number, that's a numeric variable. That's very good for us. Okay, so the next step here is to preserve this and to close this window. And now we've got all the data sitting here. All right. How do we make this into a time series data set? Well, that's pretty straightforward. XTSet. So XTSet tells Stata that this is a time series data set and that we're going to identify the individuals, the team number are the individuals, and the year is the time variable. Hit enter. Okay, so we got strongly balanced panel, meaning that for every year, 2005 to 2015, we've got all 29 teams. And delta is 1 unit, that's 1 unit of the year variable. Okay, we want to run some regressions. Let's talk about running time series regressions. There are two main types. One is fixed effects, and the second one is first differences. Let's do fixed effects first. The key here is to do xtreg. So here's a simple one. We're going to regress attendance. Where's that? Attendance on wins. So here's attendance, and here's wins, and comma FE. So xtreg, y variable, x variable, second x variable, etc., comma FE, that does the fixed effects then. So if we look at that, the main thing we're concerned about is these numbers. Each additional win seems to be associated with an additional 14,917 people in attendance for that year. Okay, so that's pretty good. What if we had not done a time series regression? What if we'd just done it like this? So REG, this is just OLS, not taking into account the panel data feature, not working with the fixed effects. We'd get a much bigger coefficient, 29,000. And so that suggests that the panel feature is important. In other words, that the fixed effects, the things which are constant across teams, make a difference. Okay, so winning still matters, but not as much, only about half as much as we would have thought from a regular regression. Here's how to do the first difference approach. It's really pretty straightforward. What we do is we do reg d dot paren attendance. I get this spelled right, wins, like this. Okay, so interestingly, we get a different result. Wins still matter, but not as much. Only 5,977, so about 6,000 additional people with the first difference approach. there's no real way to tell which is better, and what I would do in your paper is supply both. Okay, here's the second thing that we can do. Well, first of all, let's add some more variables. So besides wins, well, perhaps I'm going to do something that's, let's see, suppose that pitching is really important. So we're going to put in ERA. Okay, and let's include that. All right, well, they're pretty much the same thing. Turns out, surprisingly, higher ERA is associated with greater attendance. And in fact, the number for wins went up. Okay, if we were to do this in the first difference thing, which is exactly the same sort of thing, we just want to add ERA, and it looks like that. Now, to read this, this WD1, this line here is associated with W, the first difference of W, and ERA, the first difference. Rather different results. ERA doesn't seem to matter. Wins still matter. Okay. Unfortunately, no really good way to know which is a better one for us. Okay. Another thing we might want to do goes like this. Let's go back to this regression with attendance and wins. If we introduce this variable, L.W, that's first lag of wins. So what this is doing is it's regressing attendance on wins and on previous wins. And I'm going to do this with the XT-reg framework and fixed effects. That's what we want to do. Okay. All right, what we find here is that wins, 9627, lagged one wins, 15,879. Rather interesting results. Last year's wins predict higher attendance for this year, as do this year's wins. So, and in fact, it seems to be a stronger effect from last year's wins. What else could we put in here? Well, population, per capita income, things like that. So, how would this work if we were to do the fixed difference? And here we're going to do reg. The first difference approach is to do d dot, put the variables in parens, go like this, get rid of the fixed effect part, the comma fe, and we get a result which is actually a little bit closer to what we had before with the fixed effect. Okay, so this lagged wins does seem to be an important feature of the data. So if you got a team which was good last year, that really helps your attendance this year. If it's good this year, that helps too. And so that's pretty much what I wanted to demonstrate. You're going to need to do, in this case, I would say a few other data transformations. For example, we've got per capita income. We might want to take the log of per capita income. Let me show you another thing, which is, suppose we said, okay, winning the division, right? That's an important thing, or winning the World Series. Well, unfortunately, we can't use these variables directly because, as you may recall, these guys are in red, right? These are string variables. So were you a division runner? No, yes, etc. How do we create dummy variables here? Well, let's go back, and we will just generate a dummy variable, which looks like that. So let's see. Oh, I think I'm browsing, so get out of that and generate WS win equals, here's my World Series winner, equals yes. Okay, so if I sum World Series winner, there's not a lot of, should be about 129th, right? 0.344. Right? Well, most of the time, teams do not win the World Series. No surprise there. There's only one per year. Okay, and then of course I can immediately put into my regression. So we probably want the lag World Series winner. Did you win last time? Okay, lag World Series winner. Well, that one is going to be sitting here, 98,000. Not statistically significant. The constant term is here. This goes as WS1 L1. This dash dash is win L1, so the lag for wins, and this is wins itself. Okay, so it's a little bit hard to read what's going on here. But that's wins, this is lag wins, this is lag World Series wins. And it's where the L1 is that in fact you see the variable. Okay, so one more thing. Suppose we wanted to generate year dummies. Okay, the way to do that is a little weird. To generate year dummies, we can go like this. Tab year, comma, gen paren year. And that generates new variables called year 1 through year 11. And then we can go ahead and run a regression like this. So let's try this. I don't think the years are going to matter very much, but I'm going to go year 1 through year 11, and a couple of these will be dropped in our regression. Okay, drop to year 5 and drop to year 1. We lose a little bit of information because we've got the lags in here. And the year dummies are pretty insignificant, except year 4 and year 3, pretty strong attendance. If we take a look at this result here, the key things we're worrying about is wins and lag wins and World Series winnings, and the answer is that these are essentially the same numbers. So year dummies don't seem to be doing anything. But in another context, they might be useful. Okay, so that's all we need to know right now for panel data.